Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can you pick 4 students from 10 students? We have 6 men and 4 women if you must have an equal number of each gender. So when we say picking or selection, definitely this is under combination. But this combination is not the ordinary combination because there is a specification that in your 4 students, there should be an equal number of each gender, meaning there will be 2 men and 2 women, the genders that are specified for this given item alone. For this, we are going to move away from using this because usually we do this for a combination. 10, there are 10 students, taken 4. We're not going to use this, and the answer is different from this. It's because if you're going to stick with this type of notation, this tells us that you're picking 4 students from 10 with genders are not specified. It could be possible that you're picking all 4 men or all 4 women, or 1 man, 3 women, 1 man, 3 women, or 3 men and 1 woman. Okay, so it's not specified here because the problem is specified. What we need to do here is to actually take into the product of each combinations. So let's start with this. Of course, the combination is in this manner. The formula is, of course, you have your n factorial over, you have n minus r factorial times r factorial. But we are going to have 2 sets of this and take their product because in this case, when items are specified, you have 2 n's and 2 r's taken on each specified n at a certain time. So say for example, let's talk about men. The first gender specified here, there are actually 6 men and you are to take 2 of them because you would like to have equal number of each gender for the 4 students. For our n sub 2 for the women, the second specified gender here, we are going to have the original 4 and we will be taking 2 at a time. Take note that we have the same number of gender that will be taken from 10 because that's what is specified here. In short, you're going to do it like this. For the first, you're going to have 6. Okay, you have this notation 6 taken 2. This is for the men, but you're going to multiply that to 4 taken 2 for women. Take note that this notation and this notation here are very different and they will yield different results because this is more specified than this. We will be having the difference of their answers later. So let's try to come up with a notation for each. So you have 6 factorial over, you will have here 6 minus 2 factorial times 2 factorial here. That's for your first combination for men. For women, so you have times 4 factorial over, you have your, we have 4 minus 2 factorial times 2 factorial here. So with that, we can now express this as this one here, 6 factorial. The result of our denominator, 6 minus 2 is 4 factorial and 2 factorial. This will be multiplied. So you have here 4 factorial over, you will have 2 factorial times 2 factorial. And by the way, you could see something that can be resolved here automatically. Okay, you could cancel because this is under multiplication. We have 4 factorial and 4 factorial here. But before that, the one thing you are making an assurance of is that the numerical figure of your denominator, not the notation, just the numerical figure, 4 and 2 will result to 6 here. 2 and 2 will result to 4. So this time, I'm going to present 2 different methods. The first method is by solving them separately. And the second method is if we could do cancellation of these results. So let's start by extending. And let me extend this here. I could show you the process because I don't have much space. Okay, for that. Okay, a little bit. Okay, so let's start with this here. I'm going to return to the 40% so that my font size will be the same. So let's have 6 factorial over 4 factorial times 2 factorial. We all know that a factorial notation is the condensed way of writing products of integers 1 to n. In reverse order, you have n times n minus 1 times n minus 2 dot until 1. So 6 factorial here can be written as 6, or the product of 6 until 1. 6 times 5 times, let me end at 4 factorial because I have 4 factorial on the denominator and I could automatically cancel them. To which is also the cancellation law will work on the second process I'm going to present you. I'm going to present all these methods so that you have options. So you have here 4 factorial and 4 factorial that's already cancelled out. Now I would like my denominator to become 1. So my 2 factorial can be expressed as 2 times 1. Since there is still 2 and 6 has a factor of 2, I have here 3 and 2. Now that my denominator is 1, the result of this is just 3 times 5. Therefore, there are 15 possible ways for us to select 2 males from 6 males, or men. I meant that the terminology used here is men. So each equal genders to 2 out of 6. There are 15 ways because it's a combination. Now let's proceed to the second here. You have 4 factorial over 2 factorial times 2 factorial. So we'll have here again 4 times 3 times 2 factorial. You will have here at the bottom. I am ending at 2 factorial because I could also cancel 2 factorial here and here. Now 2 factorial, same as earlier, is actually 2 times 1. So the factor of 4 is 2. So you have 2 times 3. So this is 2 times, this is already cancelled, 3. I have 6 ways in order for me to select 2 women from 4 women. So going back to our process here, okay? So simply substitute the results. You have 15 times 6, okay? That's the result for the first combination for men, and this is for women. We will have here a result of 90 different combinations, and this is the answer to the problem of selecting 4 students where there should be equal number of gender out from 10, given that there are 6 men and 4 women on that 10 students. Okay? This is already okay, but I would like to present another method where I could automatically use here the cancellation law. So let me copy in the meantime 6 factorial, 4 factorial, 2 factorial. I am presenting this because if some of you would like to have a shorter method, and you can do this because there are some items that already can be cancelled out. I'm talking about this 4 factorial and 4 factorial here, giving us a new form of 6 factorial, sorry, that's 6 factorial over 3 different 2 factorial notation. Okay, and again 6 factorial can be written as 6 times 5 times 4 times 3. I'll end up at 2 factorial over this 3 2 factorials, 1, 2, and 3. Of course, I could cancel this. Okay, living with that. But again, 2 factorial is just 2, so I could cancel the 2 here, leaving with 3. I also canceled 2 here, so leaving with 2. So that's a 3 times 5 is 15 times 2, 30 times 3. I will still have the same result of 40 combinations. So basically, you can answer this separately, then multiply the separate results, or you can automatically apply cancellation law here if it's easier for you to do that as well. Now, earlier I mentioned that this result is different from this because the explanation here is if you are just talking about taking 4 students from 10 with no specification of the number of male and female, it could be possible that you're taking all 4 male or men or all 4 women. or 1 and 3, not of equal gender. This would mean that this is really incorrect if you would like to jump this, and this is the correct process. Because if you would like to do so, okay, let me show here the separate answer for 10 taken 4. Okay? Or you could try this in your calculator so that we will be using our time here. So 10 taken 4 is 210 combinations. This is a lot bigger than this one here, or because in this 210 combinations, it allows us to include, as mentioned, all those 4 male combinations, or all 4 women combinations, or 1 and 3, but not of equal gender. That is why there are 210, and if that's incorrect, this is not the answer of this item, because in our item, it is specified that the number of each gender should have an equal distribution on 4, in short, 2 and 2. So just to specify this, the answer to this item is actually 90, not 210, using these 2 processes by product of different combinations. And that's counted in. Talking about getting the luck of the draw. For all in, subscribe now.